Welcome to the Deakin Alumni Relations webinar with Dr. Ben Horan. Dr. Ben Horan is Senior Lecturer within the School of Engineering at Deakin University. He is Course Director for the Bachelor of Mechatronics Engineering and the Director of the Centre for Advanced Design and Engineering Training, Cadet, VR Laboratory. His technical expertise lies in mechatronics, robotics, virtual reality and soft computing. Our webinar topic today is a haptic virtual reality midwifery training aid, when VISUO-AUDIO virtual reality are out of touch. Now I'll pass over to you now, Dr. Ben Horan, to begin our presentation.
Thank you, Farisha, and it's a pleasure as a Deakin alumnus to be presenting on a topic which is very much close to my heart and one which I'm very passionate about. We do have webcam streaming now as well, and as Farisha mentioned, we're in our cadet virtual reality lab. Behind us we have our cave in a CAD wall configuration showing a project which I'm going to talk about in introduction to today's topic. So let's proceed to the next slide. The title of the presentation, as Farisha mentioned, is a haptic virtual reality midwifery training aid when video-audio virtual reality are out of touch. I'm going to start our presentation by asking a few questions to get an idea of the demographic of the audience and how many people have experienced virtual reality, augmented reality, or who have seen a movie such as Toy Story, Avatar, or any movie which has advanced special effects or animations. So I'd like to ask the first question, who has tried virtual reality? And you can respond using the webinar tool, and so far we have 100% yes, 90%, so I'll give it a few moments till we stabilise at a result. Okay, so we're at 88% yes, 12% no. So most people have tried virtual reality. Now it's interesting, obviously this is a focus group with a vested interest in virtual reality. We ran a similar alumni event recently and it was the other way around. About 10% of people had tried virtual reality and 90% haven't. Now if we move on to our next question, which should appear for you shortly, how many of you have tried augmented reality? And for those of you who don't know what augmented reality is, it's the overlay of digital information on top of a real-world context. So again, we'll give it a few moments for the results to come through. So we're seeing now about 70% of the audience have tried augmented reality and about 30% haven't. Again, it's quite different to what we saw in our last event, but it's good and it helps me to know where to pitch the presentation today. So now I have a third question. Who has seen the movie Toy Story, the movie Avatar, or a similar movie with advanced special effects or animation? Now we don't need to wait too long to get the answers for this. As I'd expect, almost all of you have seen these movies. Now, the reason I brought up these questions, other than to help me understand the level of prior exposure to augmented reality and virtual reality, is that the technologies used to create movies like Toy Story and Avatar are key to creating virtual reality experiences. And as we talk through our presentation, we'll see that it's hard to draw a line between the virtual reality environments produced for these sorts of movies and immersive virtual reality environments. So in the first half of the presentation, I'm going to talk about virtual reality, augmented reality, what we're doing here at Deakin to lay the foundation to focus on an exciting project we've conducted in collaboration with the School of Nursing and Midwifery here at Deakin University. So as you can see from your webcam, and as we mentioned, we're in the Cadet Virtual Reality Laboratory where we focus on cutting-edge virtual reality and human-computer interaction technologies and processes. This system you can see in the background here is also the system you can see in the upper left image, which we use for a number of different applications. It's a CAD wall. It's a 10 metre long, 1.8 metre high 3D screen where we can immerse groups of people in virtual reality experiences. Now, where this sort of virtual reality technology is similar to perhaps seeing the movie Avatar in 3D, is that we're using virtual reality technologies to create the virtual environment, as well as a 3D screen to display that to an audience. And we're going to get into different types of virtual reality immersion as we move on, but if you could bear with me for a few moments, that would be fantastic. In the second picture on the right-hand side, we can see when we reconfigure our system into a cave. Now, a cave is a virtual reality room where we're able to walk in and have virtual reality content projected around us. Now, there is a question around using a cave versus a head-mounted display or a virtual reality headset, and we'll discuss that a little bit more as we go forward. But essentially, by folding our system into a cave, we're able to create a virtual reality room, enabling groups of people, not as large a groups as the CAD wall, maybe 3 or 4 people, to walk inside a virtual reality environment and provide access to environments which would be normally otherwise difficult to access. So our lab is unique. We can reconfigure our lab between a CAD wall, a cave, we can have other configurations. And we also have a large-scale haptic device which provides us the ability to provide intuitive interaction with virtual reality and to engage our haptic modality, the sense of touch, which is very much a pivotal part of what we're going to present with our midwifery training aid. Before we do that, however, I want to talk a little bit more about virtual reality in general and talk a little bit more about a project we did with a company called Flavortech. Now, this will all, as I mentioned, set the foundation for introducing our project in midwifery. So on your screen you'll see 2 links. I'm not sure that you'll be able to click them from your end. However, if you're able to type them into your web browser or a mobile phone, not the same web browser you're using for the webinar please, otherwise you'll drop out. And we can have a look at 2 types of virtual reality which are accessible to most people. And the first is 360 video. So I'm going to click that link here in case you can't and talk a little bit through what we're seeing. So here we have a standard YouTube platform, and I hope you can all see that. If you can't, please let us know via the question tab. Now, here we have a seemingly normal video played through YouTube. However, if we're to move around using video, it's a 360 video which captures all elements of the environment from all different vantages. So here we have video produced by GoPro, a couple of guys in a boat driving around the ocean responds to that. What we see is that using 360 video as a virtual reality tool provides a real some types of virtual reality environments. Of course, we need adequate bandwidth to be able to deliver this kind of experience to users, but we didn't need to YouTube platform sort of thing through any web browser. More interestingly, if you were to open this link on your mobile phone, you'd be able to hold up your mobile phone and it would turn into a virtual reality to the virtual reality. Now, we're seeing somebody here skydiving, and the reason that I chose this 360 video in particular is that virtual most benefit when we provide access to environments which are difficult to access or don't exist. In this case, it's not possible for everybody to go skydiving, just like and like it's not perhaps learn to fly a plane. And in fact, if we use the aviation industry as a benchmark, for the last 20 years or primitive virtual reality, 80% of pilot training, and then in-plane training for the other 20%. So with enough of this video, I wanted to introduce the notion of a 360-degree video as well as where this type of virtual reality really starts to provide us with advantages. Now, if we go back to our presentation, I have a second link here. If you're able to type this link in or to into either your web browser or your mobile phone, we are provided with, again, a virtual reality experience within the web browser. However, this time we have an interactive virtual reality experience. This time we're not just watching a video on a fixed timeline, we're able to navigate and interact with the scene. So using the arrow keys on your keyboard, you are able to drive, and using the mouse you're able to change the direction in which you're facing. So here we can see we haven't installed any specific software. We don't have to have a computer with an advanced graphics card or indeed a lot of processing power at all. We're able to do all of this from within our web browser. This particular application is focused on architectural visualization, and architecture are one of the domains that are starting to harness the power of virtual reality to provide people with access to, in this example, a yet-to-be constructed apartment. So in this particular one, the interaction is limited, but we are still able to drive around and have a look at the various things in the scene, and we're using HTML5 or WebGL technology to enable this to happen. So I encourage you to, after this webinar, if you're interested, have a look at more 360 videos available on the YouTube platform, as well as HTML5 WebGL interactive virtual reality experiences, either on your phone or on your web browser. Now, obviously for this webinar, it was difficult for us to provide these type of environments in the context of a headset, because not everybody has a headset they can attach to their mobile phone. But if, in case you're wondering, these types of experiences, both 360 video via YouTube and HTML5, are capable of providing an immersive headset-based virtual reality experience as well. So let's get back to the presentation. If you're wondering how to get control of your mouse again, you'll need to press Escape from the architectural visualization. So hopefully our understanding of virtual reality is advancing a little bit, mindful of the fact that most people did respond saying they have tried virtual reality, but hopefully we're getting an understanding of the breadth of different virtual reality platforms and application domains. So we are talking to you from the Cadet Virtual Reality Laboratory on the Warren Ponds campus of Deakin Universities, and for fellow geeks out there, I'll put that into latitude and longitude coordinates, which you can put into YouTube, and have a look at our campus perhaps on Google Maps, or perhaps you might like to come and visit in Open Day, which will be in August later on this year, and you can find out those details from the Deakin University website in due course. So I mentioned we wanted to talk about a project that we did with Flavortech. Now, don't worry, we are getting to our midwifery training aid and how we approach the problem with our collaborators from a technical point of view. But I wanted to show what we did for a client combining virtual reality visualization and 360-degree videos. So Flavortech are a small company operating out of Griffith, New South Wales, who develop a very interesting product. This product, the spinning cone column, is able to extract aroma and flavours from food produce, so it can go into different products. So think Big M, pharmaceuticals and things like that. Now the challenge that Flavortech presented was, how can we take their engineering CAD models and provide a more immersive virtual reality experience, but with a catch. We wanted to provide this virtual reality experience so that anybody with a web browser was able to access it. Now you probably know where I'm going with this, but we're going to show you nonetheless. So using this embedded YouTube 360-degree video, which I'm going to open up in full screen for you now, we were able to go through, again, using the YouTube platform, but this time embedded into the front page of Flavortech's website, and have a look at what their spinning cone column machine looks like. So this is a virtual experience from Flavortech's pilot production facility. So we're able to go through, if you can click and increase it to as high as you'd like, of course depending on your internet bandwidth. But we're able to see that although we can, for instance, pause the video and have a look at things from different angles. And you'll see at the bottom some different 360-degree videos have popped up, and you may like to explore those in your own time. So I'll talk as the video goes through, and you may also want to load this up at your end and have a play around. If you can, I'd highly recommend doing it on your mobile phone, and again, your phone will act as a window to the virtual world. So as this plays through, this provided Flavortech with the opportunity to embed this video on the front page of their website, enabling customers at the first instance to get a good idea about the size, the operation, and column machine. Before having access to this, Flavortech were using photos, image guide people with this information. However, providing this in an easy to access manner with namely an internet, people have a look at the complexity of in a second iteration, add information showing what various parts of the machine do. But it was a big step forward to using photos of the plant to show potential customers. So I'll stop that now and go back to the presentation, but hopefully that is continuing to help us understand the context of where virtual reality tools are. Now in terms of us and what we do on a daily basis, we work here in the virtual reality lab with industry, government, collaborators, internal and external, and certainly the project we're going to talk about was a collaboration internally with our School of Nursing and Midwifery. What we're seeing here now is our laboratory where this technology was developed in our Centre for Advanced Design and Engineering Training. And in the first instance, we have a 360-degree video created from the BIM models, or the Building Information Modelling data that the construction company used when first developing our facility. We model this environment using our in-house expertise before accessing it in real life. So you can find this video by searching, now that you're familiar with how to use the YouTube 360-degree video tool, searching file device. What I might do now is fast forward to the 360-degree video of our facility we captured in real life. So 360-degree video can be taken from a particular context, a real-world context, or we can generate it based on available model data. So here we have our 3D modeler, an essential part of our team. Within our cave, so I mentioned the cave earlier, we have 4 walls which are projected and combined to form a seamless 3D immersive view of a virtual environment and interacting with the scene and moving around virtual objects. In the middle of the scene here, you can see the mouse, we have our 6 degree of freedom haptic device. Now using this to interact with the virtual environment and have the sense of touch. And I mentioned this earlier, and I wanted to introduce it earlier so you could have a little bit of a think, and hopefully you're asking the question, well, why do we need to go beyond video and audio for a virtual reality experience? And certainly that was the case in the Midwifery training aid project. It's not necessary in all cases to introduce haptic interaction, but in the cases where it is, it's absolutely essential, and that was certainly the case for the project we're going to talk about. So I'll close this video and we'll go back to the presentation. Of course, you're free to find these videos. They're publicly facing and you can find them through the YouTube 360-degree video, or alternatively, if you were to Google the Cadet Virtual Reality Lab, you'll be taken to our lab website and you can access videos from there. So now, most of us are familiar with virtual reality, as per the question we asked earlier, and most of us are also familiar with augmented reality, which is fantastic. We have a very knowledgeable and passionate, I'm assuming, audience. Now, this is the mixed reality continuum, where we can see where virtual reality and augmented reality sit. Virtual reality is where we want to take somebody away from the context that they're in and provide them in a completely virtual environment, more often than not for training. Augmented reality, however, has a very different objective. Augmented reality attempts to keep us in our current real-world environment and add virtual information on top. In terms of augmented reality, we have 2 types. We have spatial augmented reality, where we project information directly onto a user's environment, perhaps using a projector. But more often than not, when we think of augmented reality, we're thinking about using either see-through augmented reality on a mobile phone or using a headset that projects onto our view digital information. Virtual reality, however, we have virtual reality headsets that are available, like the Oculus Rift. The Oculus Rift was used in this project. To give you some context, it's a $600 headset produced by Facebook. It has audio built in. It's robust. It works with a number of software technologies, which I'll talk about shortly. Augmented reality, however, we're still waiting for a solid, robust, consumer-ready augmented reality headset. Microsoft HoloLens will probably be first to market, and once we have that, we'll definitely see a lot more applications in the augmented reality space. But at the moment, for augmented reality, the smartphone using the see-through camera remains our primary tool. If we focus on the middle right-hand section of this diagram here, we'll see we have reference to semi-immersive virtual reality and immersive virtual reality. And we're going to come back to immersion in a minute because it plays such an important role in making sure that the virtual reality experiences we design achieve their intended objective. So here's the immersion spectrum, or the virtual reality spectrum, where we have a small amount of immersion on the left-hand side and a higher amount of immersion on the right-hand side. And let's break that down and have a look at what technologies and what design considerations enable us to have an immersive virtual reality experience, which was certainly the intention for the midwifery training aid, which we'll discuss. 2D pictures and videos have been around for a long time. They do provide us access to virtual reality information, As we discussed earlier, movies like Toy Story, movies like Avatar, do provide us with virtual reality information, but they're not as immersive as, let's say, putting on a headset and really feeling like you're inside a virtual reality environment. Augmented reality glasses sit somewhere in the middle of the virtual reality spectrum, or the immersion spectrum, somewhere in between 2D videos and the other end. The other end, where we talk about 6 degrees of freedom head tracking, we're talking about having a headset like the Oculus Rift, where we change our view, it changes our view within the virtual environment, as well as our XYZ movement in the virtual environment as well. And this is considered a highly immersive environment because we're taking somebody out of their real-world context, placing them inside a virtual reality environment. Now, some of you may be wondering, how real can virtual reality get? For me, the best answer to this question that I've come across in working in this space for around about 10 years is where you feel like a virtual reality environment is real, but you know it's not. That's the current state of the art, but we may get past that at some point in the future. We may be able to trick people into thinking they're in real reality, but in fact they're in virtual reality. And I guess some of us may be thinking of the movie The Matrix. Maybe that's possible, but certainly I don't think it'll be the case for a few years yet. Before moving on, you'll notice that 360-degree videos sort of sit in the middle of the spectrum as well, one notch to the right of augmented reality. There is a debate, are 360-degree videos virtual reality? I'd argue they are. They are taking us away from our real-world context and providing us in a different environment, but I guess they're not as interactive or immersive as you would find in an immersive virtual reality experience provided by way of a headset. Now, let's talk quickly about the reality of virtual reality. This is the second wave of virtual reality. We saw the first wave in the mid to late 90s, and it soon petered out, and we saw virtual reality really staying in high-end research labs, universities, places like that. But now, how real is it? How likely are we to see the trends in virtual reality to continue? Well, here's a diagram showing the different tiers of companies working in virtual reality. In the upper tier, hopefully you can read this at your end, but if not, I'll read out some of the names. We have Facebook, Google, Apple, Microsoft, Samsung, companies you may have heard of, Sony, Disney, Nvidia, Magic Leap, Epson, LG. If we go into the second tier, we have Time Warner, we have Matterport, iTouch Reality, Vuzix. Less popular names, but still significant investors in virtual reality technology. And then as we go down, we have more breadth, but we have companies that aren't spending as much as the upper tier. But I think the message to take away here is that there are billions of dollars of investment going into virtual reality by these companies, and from my perspective, makes it real. Now, we know now that there's investment, a large amount of investment in virtual reality by these companies, but what are these companies focusing on? Are they focusing on hardware? Are they focusing on software? Are they focusing on applications? And here's a different diagram showing where those investments are made. If we look at the lower level here, where we talk about infrastructure, we have head-mounted displays, or HMDs, which have kick-started this second wave of virtual reality. If I was to define one critical parameter which has brought virtual reality forward in the last few years, it's the Oculus Rift, now owned by Facebook, which has provided us an affordable, or questionably affordable, high-quality virtual reality headset. We also have other manufacturers working in different technologies, so eye tracking, wearables, haptics, things like that, of course applicable in the project we're about to talk about. Tools and platforms, and many of which have been used in the film and animation industries for quite a while, but are now being used to develop virtual reality content. And I think most importantly, we can look at the applications and contexts, or also content areas. We have sports and live events, computer gaming, of course. The Oculus Rift is supported by around about 100 games already, and it was certainly the computer gamers that created the demand to bring the Oculus Rift to the market enabling us as virtual reality experts with a consumer-ready headset. But healthcare is here, and we can see that there are a number of companies that see the value of virtual reality technologies for different elements of healthcare. So the hypothesis that I'd like to put forward in the context of the midwifery training aid and other applications of virtual reality is that virtual reality is not a one-size-fits-all. Virtual reality provides us significant value when we're recreating an environment which either doesn't exist or it's difficult to access. And I'd like us to sort of keep that in mind as we move forward. So now a question to you, but you don't need to answer this question. It's a question to set our mindsets as we start to discuss this particular research project. How can we train nurses and midwives or nursing and midwifery students, perhaps en masse, a class of say 60, as to what it feels like with their tactile sense to palpate and feel the abdomen, the uterine contractions of a patient in the early stages of labour? And how do we recreate those tactile sensations? So let's ponder on that for a moment. And I may bring into view our midwifery training aid and sort of keep that in the background as we talk. So the palpation that would normally be performed is using the 3 fingers on our preferred hand and palpating at the fundus to feel the intensity, frequency and duration of contractions. So here is a closer view of the device we developed, which I'll explain to you here. Before we go any further, I'd like to acknowledge our collaborators in this project who were a passionate and fantastic group of experts from the School of Nursing and Midwifery at Deakin University. We had Associate Professor Helen Forbes, the Associate Head of Teaching and Learning at the School of Nursing and Midwifery, Professor Tracy Bucknell, the Associate Head of School Research, Associate Professor Kate Nagel, Associate Professor Diane Phillips, and we've had other people involved along the way. And from the engineering or the technology side of things, which I come from, we have myself, Professor Ian Gibson, and a number of different people who have helped us make this project possible. So what we did is we developed a system using virtual reality technologies, enabling nursing and midwifery students to use this model to understand what it's like to feel for an intrapartum contraction, which is currently difficult to do. Imagine taking a class full of students into a clinical setting where we have a woman in the early stages of labour and asking them all at once to palpate a contraction in order to learn that essential skill. As you can imagine, just in terms of logistics, it's very challenging. We wanted to develop a tool which can provide a systematic way in order to learn that skill. We have patented the technology, and we are talking to major simulation companies about incorporating this technology into their training tools, which can do other things but can't provide an accurate feeling contraction. If we're to look at the pictures on the right-hand side of our slide here, we have our first prototype, which as you can tell is nowhere near as refined as our second version. The first one was named Trinity. This one is Verity. They're acronyms, but help us to refer to our technology as well as have a little bit of fun. And we informed the design of both of these prototypes based on research. So we worked with stakeholders, both experienced and novice, in nursing and midwifery, so that we knew how to represent an intrapartum contraction using the technology that we developed. On the right-hand side of the middle image and the lower image, we have the virtual environment. So when a person is wearing the virtual reality headset, they're able to see the patient and other things that we introduce into the virtual reality environment, and using the technology we developed here are able to feel, using their hand, the simulated uterine muscle contraction. When we designed our device, we needed to consider, aside from just functional requirements, what's the device going to look like? How is it going to be packaged? Because these all impact how usable the device is in a real-world setting. So as I've alluded to, we have a very diverse project team, and this project is ongoing. And one of the people that we had involved when we developed the second prototype was Mia Mao, a visitor from China. And the industrial designer helped us to develop a refined product. And you can see here, Mia has developed a coordinate system of different types of designs. So we have complex designs down the bottom, simpler designs up the top, more rational designs to the left, more sensible designs to the right. We were able to take these concept designs and liaise with key stakeholders, both internal and external to the research team, to end up with our final design. Mia also was informed by Norman's theory of emotional design to consider reflective design, referring to how the self-image of the product sends a message to its users. Behavioural design, how the correct design form, and I'm going to come back to design form in a moment, but how the design form can guide the user in knowing how to use the product without explicit direction. If the trainer is too difficult to use, if it's unwieldy and complex and scary, people are going to be less reluctant to use it, and that objective of providing a useful training aid is going to be decreased. And then the third element of Norman's emotional design, visceral design, how a simple form design can elicit users' interest. And you'll see a lot of visceral design present in some of Apple's products who focus on simplicity. So we undertook the design process and came up with a number of different proposed prototypes, and liaising with the portion of the research team residing in the School of Nursing and Midwifery, led by Associate Professor Helen Forbes, we were able to decide on our final prototype. Now, I mentioned I'd come back to form. Aside from the aesthetics and the impression that people get of the trainer, form is really important here because, as you can imagine, once we put on our virtual reality headset, we can no longer see our hands. I mentioned earlier that there were some distinct advantages between using a cave, if we folded our CAD wall into a cave, and a virtual reality headset. One of the advantages of a cave over a headset is we can't see our hands and we can't see the surrounding environment. So it's really important that the form of our midwifery training aid helps people navigate to where they need to in order to palpate at the fundus. So we took the different designs. Here we had one design which was very simple. Mia thought of it as elegant, but liaising with the other half of the research team realised it was important that we have a more accurate form representing human anatomy to help with that navigating to the appropriate area. In terms of the haptic technology that we developed, enabling people to palpate, to push down on the fundus of the simulated patient and feel contractions, we designed this using a flexible skin, a flexible membrane, and underneath a knuckle which pushes up using a single motor, and we're able to control it using a computer and a virtual reality environment so that we can have full control over the parameters of frequency, intensity and duration. Through the iterative process, testing out our technology with end users and other stakeholders, we were able to fine-tune the 3D printing. As you can see, as I mentioned earlier, we had a very crude initial proof of concept at the start, and then based on that information, we're able to move towards a more refined product. Here we can see that we have an upper layer here of the active haptic region of the midwifery trainer, and here we tried to match the mechanical elasticity of the skin to that of a typical, if we can define a typical, because all humans are different, the typical elasticity of the skin of a full-term pregnant patient, again relying heavily upon the skills, knowledge and expertise in our collaborators at the School of Nursing and Midwifery. So we 3D printed this in a rubber that had that elastic properties, and then we were able to push that up using a single motor. So one of the design considerations that was absolutely pivotal from a technology point of view was to design a technology which was robust, so it could take the abuse of being used by hundreds of students who are doing this for the first time, right? So it has to be robust. It has to be modular, so the technology can be perhaps transported from here into other existing trainers, which can do other things relating to birthing and midwifery training, and be low cost. The design we adopted is able to do all of those things, and hence why we proceeded to patenting the technology and the commercialization. So users will wear the virtual reality headset, and as we can see in the upper right here, we have some of the testing we did internally from a technological point of view. We have the Oculus Rift headset, we have Stephen, one of our engineers, palpating the fundus, but also filling other areas here provided by the form that was designed into our product. In the background, we can see the virtual environment. Now, an interesting thing we noted by the leveraging off some of the expertise in our research group, Professor Tracy Bucknell in particular, is that once we have a virtual reality environment representing a training scenario, we can introduce all sorts of things. We can introduce distractions, for instance. We can have a power outage. We can have a nervous partner. We can have different weather conditions. We can have noises. We can do all those sorts of things which would be difficult to do in a real training scenario. So aside from introducing a haptic technology, enabling us to feel what a simulated uterine contraction might feel like, we're able to create a whole range of other things that would be difficult or maybe impossible to create otherwise. So our ongoing research has confirmed that the simulator is able to generate realistic contractions, and we're continuing to develop that research so that we can further refine the technology. And as we mentioned, we have both active haptics, as in the area we palpate that's controlled by a computer, as well as the passive haptic interaction, the form of the product, as well as the elasticity of the surface which we designed and printed into the area here. In the lower diagram, we have another view of the hospital room. We can see outside, in this case, we have a changed weather condition. We have heavy raining, which provides visual and audio distraction. We have a clock on the wall, which is so that the trainees can time contractions, because, of course, again, we can't see our hands and we can't see our watch because we're immersed in a virtual environment. So there were subtle design considerations that we realised along the way. So we have some results which are published, and I'll provide links to the publications in case you're interested to read more. But we asked students, how much did the visual component and audio component, but not the haptics, help them to further their understanding and learning of how to assess uterine contractions? We had 58% of people agree. Now we need to put this into context. We are providing a capability that's very difficult to do with other simulation technologies, if not impossible. So 58% is considered pretty good. The qualitative feedback here says that it was actually quite cool. It was amazing how you can turn around and you have a 360 degree of the environment. So from my interpretation, they're talking about the immersion. They're talking about feeling like they're present in the training scenario. And there are lots of sort of things going on, and you could look around, you could see the woman and her partner, and it was helpful and you could see them and what they're doing. Another comment, the virtual reality, the visual side of the virtual reality that is, made me think about I was in a clinical setting, making it more realistic than current simulation classes. Really a key point and a key takeaway there. We also asked, using the training model, and this time we're referring to training model as in the haptics as well, and virtual reality, so the whole package, I reflected on my previous experiences in a woman's birthing experience. Of course, we asked this only to people that had experience, not new students that had yet to experience that. One response, it made me reflect on how I've done things in the past in the labour room with women as a student. So standing there and trying to feel for contractions, okay, what did I do last time? What was handy? What worked? Things like that. And it was also quite often I'd look at the partner. It was really interesting how I did that. And even though he's not really doing anything, he's technically not a part of it. So my interpretation is the person is doing two things. They're reflecting on their skills, their experience in palpating for contractions. Obviously this person has done it in real life, but I think we can all appreciate the challenges in providing that experience for everybody, as well as the distractions, you know, looking at the partner. Even the partner sitting there, in our scenario the partner doesn't do much, he sits there, he's quite stiff. What does that mean? It's one thing being trained in a scenario where there's no stress, no pressure, another one where there are all sorts of things happening as well. And then another comment, the virtual reality made me think I was in a clinical setting, making it more realistic than the current simulation classes, which was the same comment we saw as well for the other question. So as I mentioned earlier, these results were published. Helen Forbes here was the first author, and you can find that paper online and read that. Also, we do have a paper published by Mia, our industrial designer, which is open access, and you can access that as well if you're interested to learn a little bit more about how we use 3D printing, industrial design to come up with our prototype product. So I'd now like to pass over to Frisia, who will, I think, invite you to ask questions.
Thank you so much, Ben, for a very insightful presentation. Now we have time for your questions.
Edward Smith has asked, do you find many instances of simulated sickness in your research? So cyber sickness, simulated sickness, perhaps VR sickness is something we certainly need to consider. In our experience, Stuart and audience, we find that if we follow best practice in computer gaming, we can alleviate or mitigate most of the challenges with cyber sickness. Typically, we see cyber sickness occurring when people are moving around a virtual environment, they're driving around, and their inner ear is telling them that they're not moving. If we design virtual reality experiences where we stay fixed in one spot, but we're moving around our headset, so in the midwifery example, we don't need to drive to other hospital rooms. We're in a particular spot. When we're looking around, because the technology has advanced to the point where the latency, the delay between what you're seeing and the movement of your head is so low, we seldomly come across simulated sickness, but it can occur. So I think it's important that we do two things. We firstly learn based on lessons learned from computer gaming, movies, anywhere where we have vision that looks like we're moving and we're not physically moving. And then also we push, we ask for standards, we ask for IEEE standards on virtual and augmented reality around things like cyber sickness.
Thank you, Ben. Which question would you like to go to next?
Okay, perhaps we can go to Anna Hamilton.
Yeah. All up, how many years has this project taken?
That's a fantastic question, Anita Hamilton. This project has, up until this point, been going on for about 2.5 years, and it's interesting how the project started. It started as a very loose discussion between Associate Professor Helen Forbes in the School of Nursing and Midwifery and myself about what opportunities do virtual reality and more specifically haptics have in the nursing and midwifery space. And we iterated through a few different ideas and ended up with pursuing this one. The 2.5 years wasn't all at the same pace. We started off slowly. We were able to get seed funding to progress to our second prototype, so we sped up the development. So there have been various speeds of progress throughout the project, but about 2.5 years. And I think probably the key takeaway from that is if you can get people from different disciplines talking together, you can often yield quite fantastic collaborative results.
Thank you, Ben. Next question from Sandra. How much technical support would be required for this type of technology?
Look, it's a fantastic question, Sandra. We, as a research and development laboratory working inside a university, are working on a range of different projects with different levels of complexity, but we are completely mindful of the need to design things so that they're simple, robust and easy to use, and that was embedded in the design process along the way. This particular simulator has been taken to a number of different conferences. It's been taken around the world to a number of different countries. It's never failed and it's very easy to operate. So that's not the case for all virtual reality technologies, but I do think that it's possible to design sophisticated systems like this that are simple to use. So in order to use this technology, we have to plug in two cables. One is power, one is the connection from the computer to the simulator. Another connection we need is the headset to the computer, and then we need to open one application. If we don't design it simple, it won't be used as simple as that.
Thanks, Ben.
Asked, we use the HTC Vive, and due to the room scale we don't get motion sickness, and you're right, James, because the HTC Vive has a global tracking system, so it'll track your movement around the room. So you're walking and you're seeing the visual information moving as you walk, and certainly we're using the HTC Vive for some applications. One challenge, of course, is making sure that you provide the user with a way of not tripping over objects which may have inadvertently been left in front of them. But if you do have a dedicated room and a HTC Vive, or you do have a room that you can set up and remove all obstructions, certainly the HTC Vive will enable you to walk around a room and not get sick. In our cave, we also have a similar scenario where we can walk around and not get sick because we're walking, our inner ear and our vestibular system is telling us that we're walking, and we're seeing us walking around the environment.
Thank you, Ben. Next question from Ali. How difficult was it to map the physical model to the virtual reality model?
So that's a fantastic question. So we do need to make sure that when a person puts on the headset that they are standing in the right spot so that they're not feeling the physical model and seeing it in a different area. Nowadays, with the consumer version of the Oculus Rift, we started with the developer kit. The consumer version has a fantastic tracker which we can place on the desk. So that's an additional connection if used, which is able to provide us with a global coordinate system. So as long as we place the midwifery training aid in a known position to the tracker, we can align that. So it's not difficult at all. And it's a fantastic experience to feel the form of the training aid and see it and have those two correlate. Normally with haptic technologies, they're quite spongy, they're not as rigid as one would like. When we have a 3D printed, fully rigid haptic surface, we're seeing that in virtual reality and feeling the real thing. The realism is very high.
Great, thank you.
So Stuart asks, do you have measures on immersion? How realistic is the haptic simulator? Have you measured real contractions and used that data to drive the simulated contractions? So the last part of your question first, Stuart, absolutely. We relied heavily upon the expertise in our research team. We didn't measure contractions per se because we too had the challenge of accessing people who were having real contractions. But what we did is we went through an iterative process where we took expert knowledge and understanding of what contractions would feel like, embedded that into our system, then asked experts to respond as to whether that felt real, and then we fine-tune that. And the results we have at the moment show us that they do feel like realistic contractions. Now, how realistic are the visuals? The visuals we've intentionally aimed to match the current level of graphics, so computer game level graphics that are used in other medical training simulators. There's not a lot of virtual reality, but there are gamified training simulators, and we wanted to match the level of graphics. But it is possible to have near photorealistic rendering if designed correctly, so we can make scenes highly realistic, or we could make them look very realistic by using 360-degree video where we capture real scenes and place that in the virtual reality environment. Measures on immersion are a tough one. I'm not aware of any measures for immersion, but certainly hope to see the wider virtual reality and simulation community having a look at how that develops. We now have headsets which you can buy for under $1,000, coupled with a high-end computer, opening the research challenge and access to that type of technology to a range of people who before didn't have access to virtual reality environments, a high-end virtual reality lab. So I do hope that the measures for immersion do pop up in the near future.
Thanks, Ben. Can you see this developing further for midwifery?
So Melanie, I think so, absolutely. Our team are extremely passionate about looking at how we can use this for not just other elements of midwifery, but other elements in healthcare and healthcare training. So in midwifery, I think the holy grail would be the birthing process. Can we develop a technology that provides us the visuals, the audio, and the haptic technology of the birthing itself? So hopefully we can get there. We did start at that end of things with the project originally, but realised it was going to be slightly challenging, but we hope we do get there one day.
Yeah, great. Farah's asking, how much would something like this cost?
So it's a fantastic question. As I alluded to earlier, there was a strong emphasis on a few things throughout our design, and one of them was cost. This type of technology, this specific task trainer, training for feeling contractions, we think would be in the order of a couple of $1,000s to produce. A manufacturer, of course, and a seller would add their margin to it. But we knew if it wasn't going to be affordable, nobody would use it. So whether it's a standalone task trainer which can be used just for contractions, or a capability embedded into an existing simulator, it had to be in the order of $1,000 or $2,000, and we're happy that we're able to achieve that.
Thank you, Ben. Shall we go to Marie's question next?
Thank you.
Can you see application in developing countries where maternal mortality and infant mortality are very high?
Absolutely. I think if we keep the cost down and we potentially look at using smartphones. Smartphones are probably, I'm not saying they're ubiquitous in developing countries, but they are probably more accessible than a high-end laptop. If we think smart about how we couple the haptic technology with more accessible computer hardware, yes, I think it'd be fantastic. We're looking for alliances, so anybody out there who would like to talk to us about the commercialization, the diversification of this technology, collaboration in other areas of healthcare technology, I'd be more than happy to discuss. You can Google my contact details, or it's ben.horan@deakin.edu.au. So Michael's question, did we look at the resus dummies? Absolutely. So the resuscitation dummies, we did an extensive prior art search and literature review search to see whether there was a technology available like this out there, and there wasn't. The resuscitation dummies are fantastic for resuscitation in terms of intrapartum contractions and being able to provide a realistic feeling contraction. We did the initial scoping of the area to see whether it exists or not, as well as post-validation with the leading simulation companies who have confirmed that yes, what we have done is innovative. I still do think there is probably room for improvement with the resuscitation dummies that are out there, but that's a discussion for another day.
Sure. Anita's asking how many models of these are being used currently at Deakin?
Fantastic question, Anita. We have one, and that is it. We use it for our research. We will be using it for teaching soon in the coming months. It is a robust, ready-to-use prototype. We have designed that within the School of Engineering here to be a technology that can withstand use by hundreds of students. We've yet to have a failure. We're using robust Oculus Rift headset technology. The device, as you can tell, is well refined. So we really wanted to make it so that it can be used. But unfortunately, due to like most research projects funding, we have one. We hope that we can increase that in the future.
We hope so too. We're almost running out of time, so we'll try and answer a few more questions. A good question from Thomas. You mentioned one of the downsides of the headsets being that it blocks the view of the user's hands. Have you explored the idea of using motion capture to display them within the simulation?
It's a fantastic question, and yes, one thing I haven't mentioned is we can't see the user's hands, but we can provide an approximate indication of where they are using motion capture. So we're using the leap motion capture technology. It's $100, again, with the emphasis on robustness, low cost, and deployability. And it sits in here. When we're using the headset and we're approaching the model, we do get an accurate, an approximation of the position of the user's hands. So they do know they're approaching the model. The problem is the field of view of the device, and embedding the device into the technology, we can't track the user's hands all the time. So we do give them some indication, but once they're navigating the model, we can't see it anymore. So we need that form to guide them to where they need to be. So fantastic question, and yes, we have.
Thanks. Would you like to pick the last couple of questions?
Sure, fantastic. So we have Joanne asking, we use Lidl SimMum in our medical school. The inner workings are very clunky. Have you seen one in action? You are most welcome to come and see her deliver. Yes, we have SimMum used here at Deakin as well. Yes, they're very complex and complex devices. I'm not really in a position to comment on whether they're clunky, but yes, they're complex, and we use this as a constraint. We wanted to develop our technology such that within a very crowded workspace, we can still deploy what we're doing into something like SimMum. So SimMum is fantastic. SimMum, you can do the delivery, you can, I think, have lactating breasts. There are a whole range of different functions. Providing realistic intrapartum contractions isn't one of them. There is an airbag model. I'm not sure if it's in SimMum or another simulator, but it's rather crude. And what we wanted to do is, for those that do want to have high fidelity simulations, create the opportunity to do so. So perhaps for a final question, perhaps we can go to Mary and said, I may have missed this, but can you change the length, frequency, and intensity of the contractions? Absolutely, Mary. And it was funny to be sitting down at an interdisciplinary collaborative research meeting and be talking two completely different languages. We settled on the terminology length, frequency, intensity and duration, which made sense to both parties, and certainly we're able to change how long the contraction lasts for, the period of time between the contractions, which corresponds to the frequency, and the intensity. We can have mild contractions, we can have strong contractions, and we can really change that value anywhere within a minimum and maximum force that we can achieve with the actuators inside the device. And there are a few comments thanking us for the talk, so you're more than welcome. And again, if there are further discussions, you're more than welcome to contact me via email.
Thank you so much, Dr. Ben Horan, and thank you for all our participants today. We had some really good questions, and as Ben has mentioned, if he could not answer your question today, please feel free to email Ben at ben.horan@deakin.edu.au. That's it from us today. We hope you enjoyed the webinar, and we hope you can join us again next time.